Triangle is half times the product of the base and its height. Yep, typical math lesson. Teacher jumps into a formula and then presents various concrete examples of its use. But wait a second, how did we get there? Well, the teacher might present a little bit of a proof, but that only raises a little more questions. How did you come up with that? We never really get an understanding of how that works, and then we're left to think of math as just a set of formulas and algorithms that we really don't know how to use. So, what if we just played around a little bit? Suppose we just wanted to draw this, a triangle in a rectangle, and we want to figure out how big the triangle was and how much of the rectangular triangle took up. It's not really practical. The triangle doesn't really have any real purpose. It's not really representing anything. It's just really just frivolous to think. But if you just decide to draw a little line dividing the rectangle, you can see that it's split apart so that each small rectangle is divided exactly in half by the diagonal. So there's exactly the same area inside the triangle as outside the triangle. So, from just this frivolous doodling, we end up getting something useful. This example, taken from a paper on math education by mathematician Paul Lockhart, demonstrates that there are two very distinct ways of teaching. One, the first one, presents it as one of a tool for science, where you can present it for applications in science, economics, and engineering. Another just does math for the sake of math, where there aren't that many applications, but it's more of an intrinsic art. Now, both of these have their benefits and their drawbacks. Teaching it as an art takes away from the obvious applications, and you don't get that much of an insight into how to use it in very specific circumstances. But teaching it in the first way takes away from the sort of intellectual curiosity that many mathematicians seem to love about math. So neither of these two ways alone constitutes a really complete way to teach mathematics. Now, from the research that I've done so far, it seems that the best way to do it is actually to split up the math classes into two different classes, one focusing on each of the two methods of teaching. So, obviously there needs to be a lot of research to be done to go into this. So the first thing that I did was to, let's take this off the screen. The first person I interviewed was a guy named Yuri Borky. He's a teaching assistant at Stanford and a triple gold medalist at the International Math Olympiad, which is basically the Olympics of creative mathematics. So he's a pretty qualified guy to talk about the distinctions between math as a tool for science and as an inherent art, or the two different modes of teaching art. So when asked about the purpose of math teaching, he said that it depends on the person you're teaching it to. For some people who really love mathematics, mathematics teaching should be able to stimulate that passion. But for people that just want to use it for other purposes, it should be able to prepare them sufficiently for that. But when I prompted him with other questions, he said that while he's seen a few teachers that can effectively balance these at the same time, very few exceptional teachers, there aren't really that many teachers that can do that, and it's really difficult to do that, and it can't be expected of all teachers. So, in that way, it seems like the obvious thing to do is to kind of split them apart into two different things. So they don't have to be balanced at the same time, but you can get the same freedom from both styles of teaching mathematics while teaching it at different times. So, essentially, this method of teaching will allow more freedom for both educators and the students, while still allowing them to get both styles of mathematics complete. Thank you.
Thank you.